Hello there, folks. Hope we're all doing well. We have a minute and 17 seconds until we get started with our second to last day of Advent of Code for this year. Let's take a quick look at the leaderboards. Personal stats, 927 and 850 last night, so no complaints there. And if we look at our private leaderboards, Kevin Chung did in fact finish last night, so I have a fellow compatriot here at work, and we can look at the other one, but, you know, just cause. Yeah. I got 2 more shots this year. If we look at my personal stats, looks like good days are in like the top 1,000, right? Outside, inside, outside, 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 outside. Pretty much outside, inside, outside, inside, outside, inside, outside, inside, outside, inside, inside. So as we go along, it's more and more common that I'm ending up inside the top 1,000. And we can see by our results here on the right that I'm usually getting faster rather than slower. In particular with this one, wow. Anyways, we'll hope that luck continues. I actually haven't done all of this stuff, so let's see if we can get that done real quick. New file, level 24 data.txt. Add that to GitHub, please. Open level 24 and Control R L15 needs to be replaced with L24. Replace all, and we're off. Nope, that's day 23. Day 24. Blizzard Basin. With everything replanted for the next year, and with elephants and monkeys to tend the grove, you and the elves leave to the extraction point. Partway up the mountain that shields the grove is a flat, open area that serves as the extraction point. It's a bit of a climb, but nothing the expedition can't handle. At least, that would normally be true. Now that the mountain is covered in snow, things have become more difficult than the elves are used to. As the expedition reaches a valley that must be traversed to reach the extraction site, you find that a strong, turbulent winds are pushing small blizzards of snow and sharp ice around the valley. It's a good thing everyone packed warm clothes. To make it across safely, you'll need to find a way to avoid them. Fortunately, it's easy to see all of this from the entrance to the valley, so you make a map of the valley and the blizzards, your puzzle input. For example, this. The walls of the valley are drawn as hash, everything else is ground. Clear ground, where there is currently no blizzard, is drawn as a dot. Otherwise, blizzards are drawn with an arrow indicating their direction of motion, up, down, left, or right. The above map indicates 2 blizzards, one is moving right and one is moving down. In 1 minute, each blizzard moves 1 position in the direction it is pointing. Due to the conservation of blizzard energy, as the blizzard reaches the wall of the valley, a new blizzard forms on the opposite side of the valley moving in the same direction. After another minute, the bottom downward blizzard has now been replaced by a new downward blizzard at the top of the valley instead, here. Because blizzards are made of tiny snowflakes, they pass right through each other. After another minute, both blizzards temporarily occupy the same position marked 2. After another minute, the situation resolves itself, giving each blizzard back its personal space. Finally, after yet another minute, the rightward-facing blizzard on the right is replaced with a new one on the left, facing the same direction. This process repeats at least as long as you are observing it, but probably forever. Here's a more complex example. Your exposition begins in the only non-wall position in the top row and needs to reach the only non-wall position in the bottom row. On each minute, you can move up, down, left, or right, or you can wait in place. You and the blizzards act simultaneously, and you cannot share a position with a blizzard. In the above example, the fastest way to reach the goal requires 18 steps. Drawing the position of the expedition as E. One way to achieve it is as follows. It's going to be a really hard graph traversal problem. Minute 10, minute 11, minute 12, minute 13, minute 14, minute 15, minute 16, minute 17, minute 18. What is the fewest number of minutes required to avoid the blizzards and reach the goal? Get your puzzle input. Okay. Yikes. So let me think about this for a minute. So I basically want to simulate every column and every row independently, and then I can figure out where to move based upon like what allowable moves exist from a position. So gotta click the thing so the music shows up. Fantastic. I'm going to make a static class blizzard row. And then I want like a list integer initial blizzard blizzard row. Initial right blizzard positions list integer. And I want the same thing but for left. Left blizzard positions. I need blizzard row. Initial left positions equals new array list. And same for initial right blizzard positions equals new array list. Fantastic. Let's put these in the same order that they show there. No, I want left in front of right. And left is the ones moving to the left and right is the ones moving to the right. Fantastic. And then I want void add left facing blizzard int index, and then I want initial left facing blizzard positions dot add index, and then I basically want to do the same for right. And I'll explain why I think this makes sense in a moment. Cool. And then I want list integer valid positions after time int minutes passed. Then I want a list integer. Let's call this invalid positions after time. New blizzard positions equals new array list, and I want this to be initial left blizzard positions dot size plus initial right blizzard position dot size. Fantastic. I wanted to move that. There we go. That looks better. For integer right starting index. And we can basically treat our grid as like this wide, so from 0 to there. Let's see. Let's go left starting index. Left starting index in initial left blizzard positions. I want new blizzard positions dot add. Let's return a set actually. Set hash set. There we go. Let's import set. New blizzard positions dot add left starting index plus minutes passed. It's actually facing to the left, so it's minus. And then we want this. I also want int row width. Int row width. This dot row width equals row width. Fantastic. Plus row width percent row width. That seems right to me. So it's going to go to left however many minutes there are. We can add the row width and percent by the row width, and it'll end up in the same thing. And then we're basically just going to do the same thing, but for the initial right-facing blizzards, except this is just going to be plus. We don't have to add row width, and we can just percent row width, and we'll be good. Fantastic. And then I want to return invalid positions after time. Sorry, I want to return new blizzard positions. Fantastic. So we basically want the same thing for like rows and column. Blizzard row. Let's shift F6 or column. Let's call left as shift X. Nope, undo that. Shift F6. Initial backwards traversing blizzard positions. F6. Initial forward traversing blizzard positions. Fantastic. Excellent. So this is really hard to read because it's not that big, but that's okay. Oh yeah, totally viewable though. So we can even make this a little bigger. It'll be fine. Fantastic. So now that we have all that, we basically want, let's figure out the test. Private static final int 1, 2, 3, 4. Test row width equals something. Test column height equals something. Row width equals something. And column height equals something. Cool. So what is our test row width here? We basically have 1, 2, 3, 4, 5, 6. Test row width is 6. Text column height is 0, 1, 2, 3. So 4. And the actual row width is, let's just take this whole thing and put it in our test data. So the actual row width is 102, so 100. And how many columns are there? Or the column height is 37 minus 2, so 35. That seems right. 35. So then the cool. So now that we've got these blizzard row or column, I basically want like a wrapper class, like static class blizzard grid. Int row width, int column height, and then I want to have a list blizzard row or column blizzard rows, list blizzard row or column blizzard columns. So now for my blizzard grid, this is going to need to take in an int row width and an int column height, and then I want this dot row width equals row width, this dot column height equals column height, and then I want blizzard rows. Blizzard rows equals new or int I equals 0, I is less than column height plus I. Blizzard rows dot add new blizzard row or column, and we should rename row width here. Row width or column height. Cool. And now I need to take this. I need to add a T at the end. Yes, fantastic. Add new blizzard column. Okay, so this blizzard row, we want to add a row, and we're adding it for the number of columns, and each row needs to know what the row width is. And then we need to do the same thing, but we need blizzard columns dot add new blizzard row column height. And this needs to happen for row width. Fantastic. And then we also need blizzard rows equals new array list, and rows as the size of the column height. Blizzard columns equals new array list, row width. Fantastic. Okay, cool. So now we're good there. And now we want void add blizzard character C int x int y Then I wanna, so switch C case. We want up. We want case down. We want case left. And we want case right. So for up, so for X and Y, so for up, we want to say that is blizzard columns dot get, and which column are we getting? We're getting X. Okay, so blizzard columns dot get X dot add. Okay, we need to, this needs to be changed. Add backwards facing blizzard. This just needs to be add forwards facing blizzard. Fantastic. So add backwards facing blizzard, and this should be Y, because that's how deep it is. Break. Now we want to do the same thing, but for add forwards facing blizzard. Now we want to do the same thing, but we want blizzard rows dot get Y dot add backward facing blizzard X. Yes. And we want this same thing. And this is add forwards facing blizzard X. Fantastic. So that should be good. So now when we go through, I'm going to say if use test data private static final boolean use test data equals true. If use test data, so we want blizzard grid. We want blizzard grid equals new blizzard grid, and that needs what, a row width and a column height. Test row width, test column height. Else blizzard grid equals new blizzard grid row width column height. Cool, we're good there. So while scanner dot has next line, so which row equals 0. At the end of this, I want which row plus plus. String line equals scanner dot next line. So now I want for int I equals 0, I is less than blizzard grid dot, this is a row width, yes, plus plus I, if line dot caret I dot not equal this, then I want blizzard grid dot add blizzard line dot caret I, and then I want, what is X? X is I minus 1, and then Y is which row? Fantastic. So now we end up with all the blizzards. So now we've got this thing where we can query and say like, hey, what are our valid moves after a certain period of time? Which is great. So now what we need to do is we need to like try and like depth first search this thing, or actually probably breadth first search this thing. Okay. All right. Okay. Cool. So we've got all our stuff there. So now what we want to do is just want like a route length right now, and then we can actually modify it to give us the actual route later. So private int shortest route blizzard grid. Here, we'll just go ahead and do this because we know it's coming. Int start x int start y int end x int end y. And int time already spent. Is this really the right? Do we want to do this in a queue? Or do we want to do this in recursive? Let's use a queue. So int shortest route just needs to take in a blizzard grid to start x blah 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 blah. This is fine. So now what I need is I need a representation of a point that we can add. So static class current path point to x int y and then int time passed so far, the current path point. You should basically give me all this stuff except with commas. This dot x equals x, this dot y equals y, this dot time passed so far equals time passed so far. I'm probably also going to need a like compare to or whatever, but that's fine. So now what I want is so I want queue. Is that what I've been using? It's the queue. Priority queue, that's what I'm looking for. Priority queue, current path point, queue equals new, priority queue, new, comparator current path point, return O1 dot time passed so far minus O2 dot time passed so far. Fantastic, cool. So we're good there. Queue dot add new current path point, start x, start y, 0. Let's see. Well, true, I guess, because we're doing breadth first search, so it doesn't really matter. I want current path point equals q dot poll. If current path point dot x is end x and current path point dot y end y, return current path point dot time passed so far. Fantastic. Now what I need is now what I need is like blizzard grid dot like is available at, right? Is that a method that we have so far? Add blizzard? No. Boolean point available at time. Int x, int y, int t. So now I want x determines the blizzard columns. So I want return blizzard columns dot get x dot invalid positions at time instead of after time. This should be at time. Let's just rename that real quick so it's less confusing. At time t, is that right? Dot contains y. So we want to return this does not contain that. Let's just go ahead and move this up on the same line. It'll be a long line, that's fine. And not blizzard rows dot get y dot invalid positions at time t dot contains x. Is that it? If there's no blizzard at the row or column, then we're cool. Does it fine. So now what we need is we need all the points. Cool. So get next possible points. See if they're valid. So if x is greater than, if current path point dot x is greater than 0, then if blizzard grid dot point available at time current path point dot x minus 1 y current path point dot time passed so far plus 1. It's gonna be current path point dot q dot add new current path point x minus 1. God damn it. Just this same set of parameters. Just do that for me, will you? Fantastic. Okay, so if x is greater than 0, which is fine. The y gets weird. If current path point dot x is less than blizzard grid dot row width minus 1. Yeah, it seems right. Then I want this same set of things that are in here, except with pluses, except for minuses. So I can go in here, and then actually we're just going to take this whole thing and move it here. And really, rather than nesting this, we can just and. There we go. That's better. Much better. Same thing here. This is this, and x plus 1. X plus 1. Cool. So now, what are we upset about? Are there too many of these? Is that what we're mad about? Yes, it is. Fantastic. Wonderful. All right, cool. We're all better there. So now we want the same set of things. If current path point dot y is greater than 0, or current path point dot y equals 0. Oh gosh, have things frozen? Okay, maybe not. Maybe they just froze on the thing over there. Let's go over to my Twitch. Yeah, things are still working. They just froze once over there. That's so weird. Okay, we're good. 0 and current path point dot x minus 1 and blizzard grid dot point available at time current path point dot x current path point dot y minus 1. No, this is, we don't need this weird thing here. The only thing we need for is the last one. Cool. So when we're inserting into the grid, like x starts at 0 and x ends at row width minus 1. And then for y is going to start at -1 and it's going to go to the thing +1. So that's the real thing. But the other thing is just that it's gonna go down, so it's fine. It doesn't matter. And current path point dot time pass so far. Now are we happier? Kind of. Then what I want you to do is q dot add, and we have to remember to add the hold still point. Oh, our termination condition is not quite right. Well, it can be. Q dot add this set of parameters. New current path point. This set of parameters, please. Fantastic. Okay, now for the last one. If current path point dot y is less than blizzard dot column height. Yeah, and we're actually, I just want to give it this index and then just say +1 because that's always going to be empty, right? It doesn't have to be, it only does because all the things that are here on the left and right have no verticals, which helps us, but that's a quirk of the input, so we're going to make use of that. So then we're not going to code the weird stuff, and you can just copy this. By +1. Oh, this seems to be time pass so far. +1. What am I doing? +1. And I want q.add your current path point, blah, blah, blah. Fantastic. And then if blizzard grid dot point available at time at current path point dot x current path point dot y current path point dot time pass so far +1. We just want to add q dot add new current path point and then this. Fantastic. So now we just need to call shortest route, right? Shortest route time plus or write a static int. Shortest route, blizzard grid. Start x is 0. Start y is -1. End x is blizzard grid dot row width -1. End y is blizzard grid dot column height -1. And then I want to take this thing and I want to add 1 +1. Cool. So now let's get our test data in there so that this thing starts right. This is our initial state, except there's an E there, which I don't like. So let's go here. Here's this, and our X starts at 0, and our Y starts at -1. And then 2, 2, 3, 4, 5. Yeah, so we want to end up at 5, 3, which is this -1, this -1. Fantastic. And then we're just going to add 1 to that. Okay, let's click to make sure the music keeps going. I want to call level 24 dot part 1, and let's see what I get. Legal start of Russian. Which round equals 0. Fantastic. Index forward of bound for length 4. Oh, where do we do that? Part 1, add blizzard, a caret, I -1. All right, let's debug. Let's see what's going on. Which row is 0? Row width is 6. I is 2, I is 3, I is 4, it's 5. So now we're good. Which row is 0? Which row is 1? Oh. Oh. Crap. Should also be which row -1. Crap. Okay, that's all it is. Because we need to skip the top row. Okay, we're still... Well, point available at time. Oh yeah, let's go to if x is 0 and y is -1. Need an extra parentheses here. Or x equals row width -1 and y equals column height. Turn true. Otherwise, just do this. If y is less than 0, if x is less than 0, or yeah, that's all we need. That's fine. We're getting stuck with the standstill part on the first one. And current path point dot y greater than -1, and yeah, that should be fine. And we want to add this same thing here, just because the weird initial condition we have. Next 4 out of bounds. What's going on? Point available at time, shortest route. Less than column height -1. We want less than row width -1 is already there. Yeah, cool. Just bounds checking stuff. You know, normal things. Shortest route time is 13. Is that right? This is not right. Ah, oh, crap. Now for each one, where's current path point? This current path point. List current path point, previous points. Yeah, we made this real gross. Previous points equals new array list. Fine enough. current path point. Next point from step. X int y. Current path point next point equals new current path point x y time passed so far plus 1. Next point dot previous points equals new array list. Previous points. Next point dot previous points dot add this. Return next point, and so now we actually want the next point from step rather than creating a new one. Q dot add current path point dot next point from step this. So now I want to do this same thing in the other places. We just have to delete this last thing. We basically never want to be creating these on their own anymore, except for the first one. There we go. New current path point. Delete the last one. Why is there a space there? Delete this, click on the music so that it keeps playing, so that I don't go insane. Then if debug. Let's go ahead and private static final boolean debug equals true for now. If debug for current path point in current path point dot previous points system dot out dot println. Just put a T in there real quick. System dot out dot println printing out path. And let's just add add override to toString method. Override implements method toString. Okay. Return RL plus this.x plus this.y plus. Good enough. Cool. So now if we run this again. Oh, nope. Let's stop running. Point. Then we want system.out.println current path point. Then we want system.out.println. There we go. Should be better now. I just want to see what the route it thinks it's taking is. Okay, 0, 0, 0, yes. 0, 1. Why does it think it can go to 0, 0 again? Oh, no. This toString at time. Actually, let's do it this way. Time plus this dot time passed so far plus. Here, now run again. Let's make sure time is counting correctly. All right, so I'm looking at this test data. Something's a little bit off, so let's debug again. We're fine there. Let's go to shortest route and go to here. So So go forward and take it to shortest route. Oh, don't care about this. Take me to shortest route. Great. So now I have the blizzard grid. Grid dot point available at time, and let's try a bunch of points at time 0. See whether or not we're getting the right stuff. So 0, 0. Is that available at time 0? False. Is it available at time 1? True. Fair enough. Is it available at time 2? Also true. Is it available at time 3? False. Cool. So when we look at the console though, we're getting 0, 0 at time 3. So how is it doing that? Okay. We're gonna have to debug our way through. Cool. While true, blah, blah, blah. So current path point is -1, 0. Yeah, we're not at this, so that's fine. Current path point is 0. It's not greater than 0, so we can go to the right. We also can't go there, so step over. Y is not greater than 0, so we can't go up. Our only choice is to be able to go down or be able to stay where we are. Current path point at Y is less than. This is true, and point available at time. So let's see. I'm sorry, 1 second. Short route. Time passed so far. Are we always +1? God damn it. We just missed one of the +1s there. Okay. Stop. Rerun. Nope, now something else is wrong. Okay, let's see where we are. Okay, minute 1. Minute 2, that's fine. Minute 3, that's fine. Minute 4, 1, 1 shouldn't be allowable. Let's debug and see whether or not we're getting that. Blizzard grid, point available at time. 1, 1, 4. But it's not. Okay. So, why is that? So we're fine. Let's play forward. 2. So time 3, like 0, 2 is what we want. Should we just like straight up aren't getting? And time 4, 1, 1 is already there. Oh. Oh yeah, that's the other thing, is that we want like a priority queue, but like not if the stuff already contains. So why? X is 0. We should be seeing 0, 2 here. Why did we never see 0, 2? Stop and redebug for me. I feel like we should already be done here. Let's look at our queue. Has 0, -1. That's what we expect. Let's play. Now it's 0, 0 and 0, -1 at time 1. Now it has 0, 1 at time 2 and 0, 0 at time 2. Could have 0, -1, I guess, but that doesn't really. Also has 0, 0, 0, -1. Oh, let's also override current path point dot equals. Equals. Return this dot x. No, because they're gonna have different paths before that, but that doesn't really matter. But also, we don't really care whether or not you took a different path. If you get to the same point at the same time and the path and the time is the same. return false. If not object instance of current path point, return false. Current path point O equals current path point object O.x, and this dot y is O.y, and this dot equals O dot time passed so far. Cool. Then I don't really care otherwise. Let's make this a little helper method. Right, static void add to queue if not already there. Then I have a queue current path point queue current path point candidate. If not queue dot contains candidate queue dot add candidate. Let's make this a priority queue so that it plays nicer. That's all we got to do. So now I just want current path point next equals this, and then I just need add to queue if not already there. Queue next. I basically just want to put this in a bunch of different places, and then I basically want to go this instead of all this stuff that already is there, which is this. So this can go here. Man, sure is annoying to have to edit all these lines. Sucks to be me. Know what I mean? You do know what it means. Cool. That seems better. Cool. All right, well, let's debug again now that we're not going to get as many collisions. Cool. Yep, fantastic. So the queue 0, 1, 0, 0, 0, 1. Yeah, nice, cool. So now we just end up with those three paths, which makes sense because at time 1, if you're here, you can either be at 0, 0, 0, 1. You could only have ended up in any of these three spaces, but now your candidate places at minute 3 should always just be here. Like, I guess you can go to -1 if you want. But yeah, if you're here or here, you should have to go here. So 0, 0. So this is 0, 0. So we're not at the end condition. X is not greater than 1, so we're not going to be able to go to the left. Yeah. Point available in time. Cool. So give me blizzard columns dot get x dot invalid positions at time t 0 and 1 dot contains y. So then this should return false, right? Great, cool. So it didn't add there. Okay, just show me the queue. 3, 0, 1. Yes, that's right here. Fantastic. Cool. 0, -1 is still fine as well. Yeah, because we can basically be here or here. So now let's run again. keep looking at Q. What's our current position? 0, 1. Fantastic. Doesn't get out of the queue. Great. So our queue seems really sensible right now. So if we just go to the next one. At minute 4, you could be at 0, 0. Or you can be at 0, -1. So that seems fine. We play forward. How? How did we get 1, 1? Okay, cool. Well, we know when to check now. Stop and rerun. Play, 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 play. So time 3 is fine. Time 4 is here. This is the one. So we're at 0, 1, which should be here at minute 3. And we can't go there. So why does it think 1, 1 is available? So Blizzard Grid point available at time 1, 1, 4. It says true. Why? Why are you saying true? Okay, cool. That's fine. We're trying to see 1, 1 right now, which is going to be x, y plus 1. Is that right? Current path point. Sorry, it's x plus 1, y. So step down, step in. This is true. So what should be wrong here? We should get Blizzard rows dot get 1. So Blizzard rows dot get 1 doesn't really matter. Dot invalid positions at time 4, 0, and 3. So I need to go into invalid positions at time. Cool. So it's hard to tell which one we're in. Blizzard columns. So 2 and 3. Let's go back at the beginning. So in this column, there's 2 and 3. They're pointing at each other. That's fine. It's the Blizzard row that matters. Let's just do this. 1, 4. Why did it not get 5? Are we missing? Let's go back to where we're parsing in. I0. This. Yes, we're missing the I plus 1. Crap. Okay, stop and rerun. Okay, we're close. 0, -1, 0, -1, 0, -1, 0, -1, 0, 0, 1, 0, 2, 0, 2, 1. 1, 1 at time 8. 1, 0. 2, 0. Minute 11 is wrong now. Okay. Let's debug. Let's wait until we get to our minute 11s. Show me the queue. Seven, time 8, time 9. Our queue stays really small, which is nice. Time 10. And 10 we care about 0, 2, that's fine. So time 11 we care about 0, 2 still, yeah. So that's... Whoa. Why do we only have 0, 0, 0, -1, and 2, 2, 0? Oh, 2, 0 is fine. So this is the one we care about. So go here. So time 10, 2, 0. Current one is 2, 0. Fantastic. Cool. So we could try and go to the right. It's not going to let us. Now we could try and go. Oh, sorry, that was to the left. This should be to the right. Again, I can't. What was the problem with the console here? That's fine. Doesn't let us. 2, 0. This. Current path point dot y, blah blah blah. So now what did this add to the queue that we're upset about? 2, 1. Okay, so we're probably have an index wrong in our thing as well. Should we skip a row? So we're going to the right in row width now. Yeah, so nope. First of all, blizzard grid dot point available at time, 2, 1, 11? True. And that should be false because of a row thing, right? Like that's the upset thing that we have. So point available at time, let's click here, let's do this. And then if I do this again, is it gonna grid point available at time 2, 1, 11. Skip to breakpoint because it happened inside debugger evaluation, but I don't want to do that. Control Shift Enter to add watches. Cool. What about now? Nope, not what I want. Cool, so it should be the rows. Whoa. I don't get this. Oh, these two are next to each other and this one's here. Okay, cool. So 2, 1, 11. So we basically want blizzard grid dot blizzard rows dot get 1 dot invalid points at position at time this. -1, 0, -4. So we need to add. Okay, crap. So let's go to invalid positions at time because that's doing it wrong for us. This needs to be right starting index. How does this get -1 and -4? Plus. Oh, I see it now. So we need to do this. Percent row width or column height plus this, blah, 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 blah. Okay, cool. Because we're still getting negative numbers. Shortest route time, 18. Hallelujah. Okay, cool. So now let's take this. Let's put that in. Let's say use test data false. And let's try running her again. Again, I think we can move this over some. It's gonna take a minute. 249. Let's see if that's true. That's right. Part 2. As the expedition reaches the far side of the valley, one of the elves looks especially dismayed. He forgot his snacks at the entrance to the valley. Since you're so good at dodging blizzards, the elf humbly requests that you go back for snacks. From the same initial conditions, how far can you make it back from the start of the goal, then back to the start, then back to the goal? In the above example, the first trip to the goal takes 18 minutes, then the trip back to the start takes 23 minutes, then the trip back to the goal again takes 13 minutes for a total time of 54 minutes. What is the fewest number of minutes required to reach the goal? Go back to the start and then reach the goal again. Okay, did we do anything? So our blizzard grid is still fine. So shortest route, int start time. Now let's click shortest route. And this needs to start at 0. Okay, cool. That's fine. So now let's take all this. This can go into part 2 now, which we put in a really awkward spot. We're gonna have to move that up. Fantastic. Let's take part 2, move to the top of the file, just below part 1. Nice, cool. And first leg equals shortest route. This. What are we mad about? Oh, we don't need this. 1. Int second leg equals this same thing. So we got to change a couple things. So now our start x is what our end x was. 0. This is going to be -1. And our start y is this. Start time is first leg. Shortest total route time equals, and now we want this same thing but for third leg, where we again start at 0, -1. Oh crap. So our end y just needs to be 0, 0, because then we're cool. Our end x and our end y can be the same conditions they were initially. And then second leg, cool. So now if I go this and I do part 2, and I say run, get an issue, or are we good? There you go. You can do it. I believe in you. Just take a second to run. Current path point is greater than x and y. It's greater than -1. And current path point dot y less than measure grid dot column height. And probably going to add this here as well. So if you're not in a special index, second shortest route, blah, blah, blah. Oh, we forgot to make it so that start time gets called start time. Fantastic. Runs pretty quick though. $735. Right answer, 977. Woo, woo. Let's return to our advent calendar. So let's look at the leaderboard real quick. Let's look at our personal stats. 1123, 977. So the first thing that we wrote, we passed 150 people just by how well we wrote our solution in part 1. And if we look at the leaderboard for day 24, fastest people solved both parts in 10 minutes. Holy crap. Nathan Finner's at the top of these boards all the time. Yeah, 10:09, 7:15. Dang. This guy made up 1.5 minutes in part 2. Fantastic. And we would have had to do part 1 in 21 minutes and part 2 in 26 minutes. So the fact that it took us a little over an hour, like, not that surprising. But we wrote some stuff to make the code relatively clean. So I'm not super upset about that. And if we look at our leaderboard tier, private leaderboards, yeah, no one's done anything. Surprise, surprise. And if we go to private leaderboards, yeah, no one's going to show up here. Fair enough. Well, let's go back to day 24 and let's copy our stuff down. Fantastic. Project, new file, level 24, problem statement.md. please do add it to GitHub. Minimize this, put this here, and let's spend a little bit of time making things nice before we turn off. So with everything, blah, blah, blah. So that'll happen, Awfulsome. One of those nights, you know? Oh, blizzards of Snurf Tone Ice. Still reasonably happy to have gotten tonight's done. Just inside 1,000 for the second part, which is usually, anytime you can speed up from the first part to the second part, you know you wrote some good code as long as they're similar enough. So I'm reasonably happy to see that. On is this. Otherwise, blizzards are drawn with an arrow indicating the direction of movement. Up is this. Down is this. You having a good night, Awfulsome? What's been eating you lately in life? A map, one position right, and one moving downward. Fantastic. Was it a fun one? Oh, it was kind of fun. Here, let me explain the problem statement to you. So you see this grid? The hash marks are edges of a valley, so ignore them. The dots are places you can be, and each of these is a blizzard. So the blizzard is going to move around, so it's going to move over and over and over and over. And then when it hits to this one, when it would move here, instead it just pops back up here. So no problem, and the same with this going down. So if you look at the more complicated examples, you get just a bunch of blizzards moving around, and you have to figure out your way to walk through here without ever walking into a blizzard, which is going to murder you. So, you know, good times. Same thing. Yeah, and the solution is actually pretty interesting. You basically just hold on to some stuff where you simulate every column and every row, and then you try and figure out whether or not you can go to the right places by writing a simple algorithm. It's not so bad. Basically, you just I'll explain it in a moment, actually. Where we have the real explanation coming soon. Sounds like nerd stuff? Yeah, that's absolutely correct. That's not what you said, but I'm putting those words in your mouth. Mouse is little. There's a more complex example. Expedition begins in. You can move. Wait. Simultaneously. Oh crap! This is not. Undo this. Undo this. Undo this. This needs to be bold. Wait. Simultaneously. Goal requires 18 steps. Crap! I did that in the wrong order. 18 steps. E. Take me to the next one. As E. This is what's going on. Just taking on more responsibility at work. Kind of scary to have people depending on you for stuff. Oh yes, I absolutely 100% understand. I became a manager about a year ago, a little over a year ago now, and I totally get that. It's very stressful for a time, and then you kind of just like are used to it, and it's fine. At least was my experience. So I hope you have a similar experience. If you want to have that, I don't know, maybe you want to be stressed out all the time. But if you'd like to be less stressed out, I hope that that comes to pass. I also hope that like the prognosis that I gave is relatively accurate, and it wasn't just specific to me. Has the taking on more responsibility at work been a promotion? Have you been promoted? Are you now just the specialist person in all of your entire office land? I hope so. I mean, you frequent my chat, so that means good things should happen to you. I'm pretty sure that's how that works, right? Am I still able to do technical work, or do I have meetings all day? Not yet. Hopefully next year. Yeah, fair enough. If you work at one of the big tech giants like me, then that's definitely how it works. I got promoted this past September to staff software engineer at Google by virtue of the fact that I took on a team and ran them all right for a year. You know, if that hadn't gone well, it would have just taken the team away and been like, we probably shouldn't promote you to staff. am I still able to do technical work? Sometimes. I mean, so the trouble is my team's really senior, so they like don't really need me to do that much technical work. Like I got a lot of senior engineers on my team, and I just got several more people promoted to senior. I think now I have 3 senior engineers, 2 L4 engineers, and an L3 engineer underneath me. So like that's a pretty, compared to most teams, that's a lot of senior engineers, but we just have a lot of work for not that many people. So we could either hire like a bunch of L3s, you can hire like a couple of L5s, and they put out similar amounts of work. So for me, like the thing that I'm good at is politicking and getting people on the same page and coordinating and stuff like that. And so I can do the technical work, but like I'm not in a position where I need to do that. Now, every once in a while, we'll have like an anti-abuse problem or something, and I'll be like, obviously this. And people are like, what do you mean, obviously? And I take like 10 seconds to explain it, and they're like, oh, of course, we should be doing that or whatever. And so there are some nice things like that that come up. But in general, I don't get to do that much technical stuff, but I'm a tech lead manager. I'm not just an engineering manager. So I still get graded on whether or not I can provide good technical insight to my team. Okay, let me explain what's going on here real quick, and then I'll at least end the recording, and then maybe you and I can chat for a little bit. I want to hear more about like what your increase in responsibility at work is like, as you put in chat. So the problem we have at hand, boys and girls, is that we have a valley, and there's blizzards that move across of it, just kind of in the north, south, east, west directions, and every blizzard sort of goes across, and when it hits one end, it comes back to the other end, and it moves every minute, and you can take a step every minute. And you can step into a place where a blizzard currently is, as long as it's going to move out in the next round. So basically what you need to do is you need to figure out a path that you can walk through where you're never going to be running into a blizzard. And you'll notice that in examples like this, there's a gajillion blizzards, so there aren't that many free points. So you need to sort of like delicately dance your way like back and forth and around and whatever. And it doesn't really matter what your path is. It just matters that your path is as short as possible. So first we read the information, and there's a little bit of finickiness because you like don't want to deal with these walls. So it depends upon 1 indexing or 0 indexing or whatever. I basically just keep track of this inner grid, ignoring the walls, and then know that I want to start here and end here. So then how do I figure out whether or not I can go anyplace? Well, I call this thing shortest route. And what it does is you take a priority queue and you input the place where you want to start and the time you want to start at, which for the first one is you just start in the top left, which is this point, and no time has passed. And then what we do is we constantly grab something off of our priority queue, which is queued based upon what the start time is. You can see that all it cares about is whether or not the start time is low. And then it says, okay, well, if we're at the point that we want to end at, let's like return. And we made the point that we want to end at here, so we don't have like weird conditions where we're trying to like step outside of where it thinks the grid is. And so basically, like, if we get the endpoint, just like print out the whole path, which just made me feel nice and made sure I could debug some stuff. Otherwise, what we do is we see, hey, can we move to the left? And it does that by calling this thing point available at time. And that's the real crux here. Otherwise, I'll come to that in a second. We also see, can we move right? Can we go up? Can we go down? And can we stand still? Because if a blizzard's walking into where we are, then no, we cannot. So you'll notice that we might have multiple different candidate positions at a time. So we can't just like move forward I guess we can move forward all of the thing and then find all the candidate moves and store them all and then check all of the candidates from those moves and move forward. But I found it easier to actually just query, because what you can do is, nope, that's not the thing I wanted to do. What we want to do is we want to see, is the point available at time? So we have a blizzard grid, which has basically a list of blizzard rows and a list of blizzard columns. And that's basically like, you'll notice that a right-facing blizzard can only move to the right and a left-facing blizzard can only move to the left. And so we can basically say, like, are there any left or right-facing blizzards at this point? And are there any up or down-facing blizzards at this point at this time? And we basically check the adjacent grid points at the next point in time. And so how do we figure out whether or not any blizzard is going to be at that space? Well, we can go point available at time, and there's a special return condition for if we're like outside of the bounds of whatever's going on. Otherwise, what we do is we say, hey, give me the columns and give me the column for the column that we're in. And then give me all the positions where we know that there are blizzards moving up or down at that time. And does that contain the point where we're trying to go, like in the Y direction? And if it doesn't, then we're cool. And then we check the same thing for the row that we're in. And as long as none of those blizzards are hitting, we're cool. So now how do we even get the invalid positions at a time? Well, we know where the blizzards start, and we can figure out the left and the right and whatever, and the this and the that. So we basically take all the ones that are going to the right, and we move them around to the right as much as the time that we want to do, and then we modulo all of that. And then by like the width of the row that we're in, so that all the blizzards basically, remember, when they run at the end, they just start over. So we can basically just move them all way over and then figure out where that means about where they need to be in the row based upon using the modulo operator. And then we do the same thing for all the ones that are going the other direction, where we subtract and we have to do some stuff to like add properly so that the values aren't negative. And then we just return all of those positions in a set, because we don't really care whether or not we're getting duplicates or whatever. We just want to know, like, okay, do we have, you know, what the X or the Y values are or whatever. So when you run that across a row and a column, then you can tell whether or not the position X, Y is available, or basically, you know, for this column, you know, is this particular row available? And for this row, is this particular column available? And so we just return that. And so basically we just check all the candidate points and then we add it to the queue if it's not already there. And basically the queue just checks that if a candidate is there, and that's based upon this like current path points equals function, where it says, hey, if the X and the Y and the time pass so far are the same, then like we're cool. And that basically makes sure that we can have like multiple ways. Like, for example, you can sit at the start for a bunch, or you can like go down some and then come back to the start and then like move on. And if at time 4, you step away from the start for the last time, I don't care where you've been before that, as long as that's the fastest way to get to the point where you currently are. So I basically like take any point where paths meet again in time and just get rid of them so that we have fewer points to check. And that optimization made it run really fast. So again, you'll see, I haven't explained what part 2 is, so this demonstration won't make that much sense. So let me come explain what part 2 is. Part 1, I hope, is relatively explanatory. So part 2 just says, hey, you want to go from the top left to the bottom right, but then somebody forgot something. So now go back up to the top left to grab something that he dropped, and then go back down to the bottom right, and tell me how long all of that takes. So basically all we do is we say, hey, tell me how long it takes to get to the bottom right, and then tell me how long it takes to get to the top left, and then print out how long it takes to get to the bottom right again. So if we run this, you'll see in the console, it sets some stuff up, and then there's the first one, there's the second one, there's the third one. So the whole thing took like a second and a half to get all 735 things, which for a pathfinding algorithm, 735 steps in that short of a time is pretty dang fast. And again, as we had mentioned earlier, if we look at the leaderboard, we scored 1123 on the first part and 977 on the second part. So, you know, no points or anything, but fair enough. All right, let's go ahead and commit this real quick. Day 24 solution. Haha, command and push. Yes, I know there are warnings and issues. I do not care. This is a dirty, terrible problem. All right, fantastic. And I think so. That's all I got for you guys tonight. So peace out. Have a good one.